All right, guys, we're going to talk about Earth as a system. Now, we go a little bit farther beyond just talking about the air, land, water, life, etc. in geology. We look at it in a little bit more detail when we talk about this. The Earth is a dynamic planet, so the planet is very active. It's moving all the time. There's a lot of things that are going on. Some of the things that characterizes it is different fractions and millions and thousands of kilometers of depth and changes in its altitude and level and thickness of the crust. And we have time scales that changes in range. Through time, we've seen Earth change. You can see it in the fossil record and, of course, in rock record that shows us how many billions of years of change we've seen throughout the Earth. So this system is definitely alive. Some of the things that we want to look at for the external process is, of course, the atmosphere. The atmosphere affects the Earth itself greatly. Think about it like for wind and erosion. This is all powered by the sun. We have the hydrosphere. Again, erosion we look at. Something we find out a lot here on the farmland. Both of those things affect us in this area. So we have to manage our land and so forth because of these various systems at the Earth. It's a continual dynamic movement. And then, of course, the surface of the Earth is very affected by these things. The Earth also has some of its power that's formed from where it was formed, the core of the Earth. For example, geothermal. If your house is geothermal powered, that means it's taking the heat from the Earth and being able to power it, whether it cool it or heat it, and use energy in that way. So some of the other things we see through this is volcanoes, earthquakes, and the rise of mountains. So this is very much a powered system that occurs and is continually evolving in this system. Let's talk about the beginning of the universe, though. When it all began, it began in the Big Bang. That was a very infinitesimal, small point where all matter began. Whether you buy that theory or not, that's the prevalent theory that we work with right now. So it's one we'll operate from in geology. From this, the sun is able to form from gases and gradually begin this process into a nebula. Once that nebula forms and the star actually generates, there's a lot of leftover stuff. That leftover stuff is what becomes the solar nebula, and it gradually collects in the planets that we see today, and the moons. That's what's on the edges of the solar system. In the nebula theory, it consists of hydrogen and helium that made that, and dust that made the sun begin. It's the leftover stuff from the pre-sun that forms those planets. I've got a video attached I want you to watch. It kind of shows some of this. Then we have ice and other fragments of elements that gradually form. It's a good illustration of how that happens. We start with our very early system of the Earth, or the sun, I'm sorry. It gradually begins to rotate, becomes quicker. The mass and density gets so tight that it forms the sun. Once ignition begins of the sun, it begins to burn. And then we've got the outer stuff on the outer edges that gradually swirls and collects and collides with itself and sticks because of gravity. Once this happens, we end up with our planets in the solar system we know today. So this ends up being the theory that we operate from, which is known as the nebular theory. All right, that's it for this one. There's also a lesson attached. I have a video I want you to watch that shows this process and how it happens. It may give you a good example. We'll talk to you later.